Now, this Leaving Cert 2019 question, in my opinion, is probably it's one of the best questions really to kind of test where you are. Okay, in this, it's a Part B question, right? 45 marks. Usually it's 50, but it's 45 marks, and it kind of covers everything really from the Inferential Statistics chapter. Okay, and just a word of warning: this last question is probably like I always say, there's always questions in there that separate the H1s and H2 students from everybody else, and that's this one down here. Okay, it's probably one. It would probably been one of the more difficult questions on the paper this year. Okay, the first two questions. Then, if you look at them now, if you think back to, and if you scroll up here, if you think back to this summary of inferential statistics, so a big part of it is distinguishing between hypothesis testing of a sample mean and hypothesis testing of a sample proportion. Okay, and figuring out the difference between those and identifying the difference between those, right? And that's one of the challenges there with this first question. Part one, are we dealing with a proportion or are we dealing with a mean? Whereas in part two, we are asking the same question, and just a little tip, it's either one or the other in this case. Okay, so let's have a look at this part one here, and like it's all in just identifying, as I said, is it proportion or is it mean? And once you look at it, 174 of them of the 900 prefer whatever this is. So that's the first thing that you're looking at, is that we're talking about a proportion here. 174 of the 800 cars. Okay, and that should highlight straight away that it's a proportion that we're dealing with. So that's your first thing, right? So it's a 95% confidence interval for a sample proportion, right? So once you've identified that, you're thinking of your steps. So step one in this case is just getting what your sample proportion is. Step two is calculating your margin of error, and this is in this formula is in your log tables. Sample or margin of error for a sample proportion. There's your symbol for it, and that comes out as this. Step three then is you're getting a 95% confidence interval. So you're taking this number here, multiplying it by 1.96, adding and subtracting it from the sample proportion, and we get a value of this. Okay, so 0.1889 and 0.2461. That's our interval here in this case. Okay, and you can change that to percentages if you want, or you can leave it as decimals. And that's your answer basically. And this is just something to keep in mind there, right? So this is the formula, and technically P stands for the population proportion. Okay, so all the cars in the country, will say. So this is a sample of 800 cars, but P technically stands for the population or the proportion of the entire country. Now we don't have that. Okay, so that's just something to keep in mind. When you don't have that, it's perfectly okay to use the sample proportion instead. Okay, so it doesn't actually matter which P, the sample proportion or the population proportion, you put in here. Okay, and what this means basically is that this is the interval for our sample proportion, whereas the entire, if we were to get the population of all the countries in the country, all the cars in the country, we'd be 95% certain that the proportion of them that are new are between this value and this value. So that's effectively what that says. Now part two then, and again I think the big challenge with part two again with all of these questions is identifying what type of question is this. Is it a sample proportion? Is it a sample mean? And just a mistake here would be to think that because it says proportion here, oh, it must be something similar to part one. Whereas what your eye should be drawn straight away to is average, right? Your average speed, standard deviation. And once you see words like that, you know we're dealing with z-scores in this case, okay? Or the central limit theorem, or it could be if 95, if a confidence interval was mentioned here, which it's not, it's to do with the mean, okay? Whereas in this case, it should be kind of, again, you should be able to identify that this is a z-scores question. What proportion of the car, what percentage of the cars, what proportion of the cars, that's a z-scores question, right? So once you've identified that, then you list out your data. So the three bits of data here that are important is the population mean, right? The population standard deviation, and the piece of data that we're investigating, 95. Okay, now if you were to look at a graph, and it's always good to identify a graph in this case, so your mean there is 87.3, and 95 in this case would be up here, right? And we want to know what proportion of the cars would you expect traveling over 95 kilometers an hour. So it's this proportion. So this gives us an idea of what our answer should be. It should be a number less than 50%. So now we get our z-score. So there's our z-score formula, and our z-score is 0.64. We then go to our log tables. So the probability that it's less, the 0.64 in the log tables corresponds to 0.7389. So that's the number that we get from our log tables, right? But that's obviously not the number we're concerned about, because that's that number here. That's less than that z-score. So we want what's more than it, so we just simply subtract it from 1, which gives us an answer of 0.2611. Okay. Now what that translates as is that we'd expect 26.11% of the cars, of these 800 cars, to be traveling over 95 kilometers an hour. Okay. Now, just a little thing, and I wasn't going to mention this now, but one student once asked me why don't we use the test statistic in this case, because it's a sample of 800 vehicles. I kind of find it hard to answer that question really, because like that's not the, like, this is only used when we're dealing with the entire population, whereas we have only a sample of 800. But I think in this question what they're basically saying is that the 800 vehicles is the population, basically. So we want to know what proportion of these 800 vehicles or would you expect to travel over 95 kilometers an hour. So this is treated as the population. So that's why we don't use the test statistic one in this case. Okay, but that's kind of even you could argue that as well, that you should use the test statistic one here. But look, the marking scheme says to use this one anyway. So that's what we'll go with. Now, this is the interesting one then. So the driver was told that 70% of the speeds were recorded higher than this speed. Find the speed at which the driver was recorded. Now, this is a tricky enough question. I always find these ones are a small bit trickier, but again, it's trying to figure out that what type of question is this. And in the key thing here is that they give us the percentile at the end. Okay, or at the start, sorry. Right, so usually, like in this traditional question, you're given the piece of data, 95, that you want to investigate. You find your z-score, and then you find your percentile. Whereas in this case, we have the percentile first, which is 70%. We're looking for the z-score that corresponds to that, and then we're working backwards to figure out that piece of data here. So we're working backwards to find x, basically. Right, now, if you can spot that, that's pretty much half the battle in this case. All right. So what do we do? Again, draw your diagram just to figure out what we're talking about here. So we're looking for a z-score that takes up 70% of the data or higher than this. Okay, so we should know that when we get our z-score, it's going to be a negative z-score, and our answer is going to be somewhere around 80. If you draw an accurate diagram, you'll kind of figure that out. But like, just knowing that, just having an idea in your head of what your answer should be is definitely a big help here. So list out your data again. So again, our mean and our standard deviation are the same, and this is what we're looking for. If we were to get our z-score now at this stage, this is what we do. But obviously we don't have this value, so we can't find our z-score. So now we must use the percentile to find the z-score, and this is the tricky bit here. Okay, so we want to know what z-score corresponds to 70%. So we go to our log tables, and if you look carefully through the log tables, right, usually we go to the z-score and get the percentile, whereas now we have the percentile, 70% or 0.7, and we're looking for the corresponding z-score. And this is where it gets a bit interesting here. So if we look up here, it's one of these numbers here. You can see they're getting closer and closer to 70. Now, it's one of these then that you can pick. Okay, now I'm going to show you why in a second that it actually doesn't matter which one you pick. See the way this one is 0.69, this one is 0.7, and it's obviously between these. So you could pick 0.52, you could pick 0.53, or what I did, and I just had to complicate matters, I know, I picked the number between these two values. I'll show you how that works in a second. So I picked 0.25, but it actually doesn't matter if you're concerned that there's no 70% exactly. It doesn't matter, and I'll show you why now in a second. So as you can see, the percentile I chose, or the z-score I chose to correspond to 70% was 0.525. Now, this is where it gets interesting, right? And most students will continue with this value, right, 0.525. But the top students will know that that z-score is a positive z-score. Whereas if you look at our graph that we drew, it's going to be a negative z-score. Okay, so if you continued on using 0.525, again, you'd still get most of the marks, right? And if you finished it out, you'd probably lose 3 marks. But again, the top students will spot when they drew their graph that when they get their z-score, it's less than the mean, so it's going to be a negative z-score. So it's actually not 0.525, it's minus 0.525. Okay, so that's where, as I said, the top students will excel. So just to summarize, we have our percentile. We're now going to work backwards to get our z-score, and we're going to work backwards again then to get our value for x. So now we're just going to use a bit of algebra to figure out what x is. So we want to know what value of x will give us a z-score of minus 0.525. So using all this information, we just form an equation with all that data, and we're going to use this equation to solve for x. Okay, so just very simple algebra equation, multiply across by 12, add 87.3 to both sides, type all of that into your calculator and you get an answer of 81.06. Now here's what I was saying, that it doesn't matter. I use 0.525 if you just use 0.52 or if you use 0.53. In this case it doesn't matter, because now if you wanted a specific answer it would matter, but look at the question. Give your answer correct to the nearest whole number. So I'm going rounding this off to 81 kilometers an hour. Okay, and if you use 0.52, it would also round off to 81 kilometers an hour. If you use 0.53, it would also round off to 81 kilometers an hour. So it actually doesn't matter which value you use. Okay, so that's part 2 or part 3, and again, that would be, I would say that would be a tricky enough question there, right? So getting that out fully, that's separating your H1s and your H2s from everybody else there, really. Okay, and but back to what I was saying, even if you just made a mistake of using this z-score instead of this one, you're just losing 3 marks there, we'll say, and not ideal, obviously, but that's what you're dealing with there. Now, part 1 then is an interesting one. Usually in questions, you're asked to calculate the p-value, right? And we all know how to do that at this stage, hopefully. But in this case, they say the p-value of the test was that, so they actually calculated the p-value for us. Right? So what can the magazine conclude based on this p-value? Give a reason for your answer. And even without even reading all of this information, you know that the principle behind p-values is that if it's less than 0.05, it's a significant piece of data. Now, you need to have a good understanding of what p-values are, but that's the bottom line, regardless what they're investigating in this case. If the result is less than 0.05, the result is it's a significant result. Just the way you phrase it is important. So there's a significant change in the behavior. So this is all about the behaviors of drivers based on using poster signs and radio slots, and they wanted to know based on that hypothesis test, has there been a significant change? And because this number is less than 0.5, there has been a significant change in the behavior of drivers. A p-value of 0.05 can be deemed as a significant result, right? So as long as you're using words like that, significant, and you can explain what it means in a simple sentence like that, there's your marks there for that, right? So you're showing there that you understand what p-values mean. Now, so let's have a look at how we're going to tackle this question, right? Now, it's clearly a p-value question. Now, let's look at the traditional approach to calculating p-values, right? Well, and if you're familiar with this, you should know you start with your sample mean. You convert that into a test statistic or a z-score. Now, because it's a sample we're dealing with, and they highlight sample there, they put it in bold, it's up to you to spot that. Because it's a sample, it's a test statistic that we're using, not a z-score. Okay, now I know they're very similar, it's just a slightly different formula. We then convert that into a percentile, and then we use that to get our p-value. Okay, now in this case, we have the p-value. Okay, now let's just very briefly look at what does a p-value of 0.024 mean. Okay, now the original population mean was 87.3, and they were told that it was normally distributed. So if we drew that in a diagram, right, there's your normal distribution. Now this is the normal distribution of the sample, okay, about a sample size of 100 people, and this is your mean. Okay, now what the central limit theorem tells us is that if the mean is in fact 87.3, and if you get a sample of 100 people, then the mean of that sample should be in here, and it's very likely to be close to the original mean, right? So if that sample is true, okay. However, we got a p-value of 0.024, and that tells us that the sample of this mean was in the 2.4% extremities of this distribution. Okay, so there's obviously something wrong there, right? Now, the key thing is, as in the thing that's wrong, is that the population mean in that case couldn't be 87.3 because the sample mean is either here or here. Now, that's one of the limitations of p-values, is it only tells you that it's in the extremities. It doesn't tell you that it's in the lower extremity or the higher extremity, that value of 0.024, right? It just tells you it's one or the other. Now, in this question, they tell us that it's the lower extremity. So it's this value down here we're going to be looking for, right? So we should know our answer is going to be somewhere around 84 point something or other, right? So let's see now how we're actually going to tackle that. Now that can be tricky now to get your head around. So read back over that if it doesn't make sense, or listen back over it, right? So let's have a look at this. So the key thing is we're given our p-value, in this case 0.224. So we're starting here. Okay. Now you should remember from being familiar with p-values that this is the formula that we use for p-values. 2 times 1 minus the percentile that we're dealing with. Okay, so we can use the fact that we have the p-value to figure out our percentile. Okay, so we want to know what percentile gives us a value of 0.024. So it's just a simple algebra equation then to work out what that percentile is, and that comes out as 0.988. Right? Now, what we do then is we want to know what z-score, or well, test statistic in this case, but they're the same thing. We use them the exact same way. The formula is the only thing that's different. So what z-score corresponds to a percentile of 0.988. So we go back to our log tables, and we're looking for 0.988, and it's in here somewhere. If you look carefully for it, it's here. Okay, 0.9881, 0.9984. So we'll use this one here. Okay, and like the previous question, it doesn't have to be exactly right. It's the closest one we can find. So that's 2.26. All right, so that's the one we're going to use. So our percentile, our z-score that corresponds to this percentile is 2.26. Okay, now here's where it gets interesting then. So because we know that it's the lower bound that we're talking about, right, they mention it here, we know that our percentile is actually going to be a negative number. Our z-score, sorry, is going to be the negative z-score, not the positive z-score, right? So the z-score that we're working with is going to be minus 2.26. Now, if you can follow that, that's extremely high, an extremely high level of complexity there, if you can figure out why that's a minus, not a plus, right? So that's good if you can even follow that. Now we're on the home stretch now, right? So we have nearly all the information that we need. We're looking for this mean, whatever it is. Now, if we were to list out our data now at the start, we'd say we have for this test statistic formula, we have the population mean, we have the population standard deviation, we have the sample size. We're just looking for the mean that the sample mean that we're looking for, right? So we can now sub all of those values into our test statistic formula, and we want to know what value for x gives us a z-score of minus 2.26, and that looks like a complicated enough equation, but it's not that bad really. We just do a bit of cross multiplication, add 87.3 to both sides, and we get an answer of 84.6. And if we look at our diagram, clearly we can see that 84.6 does look kind of right for that. All right, so that's our solution to that. Now that's a tough question. Okay, so even if you follow that, that's quite good. But maybe listen over to this particular question now a couple of times, and you really, really need to have a good knowledge of p-values really to follow all of that. You need to be able to do the traditional way of getting p-values. You need to know that inside out before you can even start understanding this question.